Welcome to this lecture on single phase induction motor, and you recall that a single phase induction motor is there will be a cage rotor and there will be a single phase winding which I called winding M, coil M, main winding it is called, and we will connect a single phase voltage across this. Okay. That voltage is V bar M, and we know that if you just and suppose initially if the machine was stationary, if you switch on this supply, nothing is going to happen, motor will not run, because of the fact explanation was this single phase current will produce a pulsating field, and this pulsating field can be shown to be equivalent to two rotating field of equal strength rotating in the opposite direction, and therefore, each one will try to pull the machine with same torque in the forward as well as in the backward direction. As a result, it will not run. Another way of explaining it will not run because of the fact this alternating flux here along this line will induce voltage in this secondary. There will be current in the secondary, it will be just like a transformer, and the distribution of the current will be up or if it at a given instant, if it is crossed, the other one will be dot, like that. And therefore, the rotor field is also there, but it is along the same line as that of the stator field. So, no torque can be produced, there must be some separation of angle. However, the observation, another observation I told, that suppose with this switch on, if this rotor is given a rotation in any direction, say clockwise direction or anticlockwise direction by some external agency, suppose some initial rotation is given, then we will observe that the motor will speed up, even if you remove that initial help to the rotor. After giving some help, it will continue to run. Therefore, the conclusion was a single phase induction motor will have no starting torque, the explanation of which I have told. However, the induction motor after observing, not yet proved, but the observation is it will have a running torque working on a single winding. That was the case. Now, the analysis part what I did was that you imagine that here is single winding only. So, this motor I can think of that there is another coil M, and there is another coil which I call coil A, which is not existent, but I can imagine there is another coil existing, but carrying no current. So, that is why it is equivalent to this one. So, this current what I am telling is assumed to be 0, and here I have applied a AC voltage V m, and this is going to draw some current I m bar, and this is the rotor. So, these two situations are identical, because I will never assume any current flowing in this so called assumed winding in the quadrature axis, because the axis of these two coils are at quadratures 90 degree. Therefore, anyway, based on that, then the argument was therefore, I have got as if two windings at 90 degree, one coil carries a current of I bar m, another coil carries a current of I bar a, which is equal to 0. So, this is a unbalanced two phase current, and therefore, this currents I wrote it like this, a positive sequence current, a negative sequence current. And similarly, the auxiliary winding current will be, see, I bar M1 and I bar A1 its positive sequence current. they will be at quadrature, their lengths are same. So this is nothing but j I bar m1, and this will be minus j I bar m2, etc., of which this thing is 0 because of the fact that it is 0 because of the fact I A is 0. So, after breaking this up, then we come to know that this we got I m1 is equal to I m2, and if you substitute in equation 1, it is equal to I m bar by 2. That is what we got last time, but it is better to repeat because first time you are doing single phase induction motor. Single phase induction motor is slightly difficult to comprehend what is going on. It is better. So it is like this. Now, the moment you do like this, then I can say that you have on this motor two balanced sources, two balanced currents are flowing. One is I bar M1 and its auxiliary winding current is this one. So, I bar A1. These two currents magnitudes are same 90 degree apart because of the fact this I bar M1 and I bar A1, which happens to be equal to j I bar M1. So, this is a balanced system, fine, plus another balanced two phase current which are 90 degree apart, that is I bar M2, and in the auxiliary winding I bar A2. And what is the relationship here? Here the relationship is, because it is negative sequence, this is positive sequence motor. So the relationship is, if this is I bar M1, I bar M2 negative sequence component, it will be auxiliary winding current will be I bar A2, this is 90 degree, and I bar A2 is minus j I bar M2. That is what we have used here. So, then I am comfortable because it is then a balanced two phase induction motor, and then and it is also a balanced two phase induction motor. Only thing is, in this case the auxiliary winding current leads the main winding current by 90 degree. In this case, main winding current leads the auxiliary winding current by 90 degree. So, each one of them, if you consider them separately, and then I will superpose the results, assuming linearity, all these things. So, in this case, the rotating field will be moving from the leading to the lagging phase, and in this case the rotating field will be moving from the leading to the lagging phase, because in this case the main winding current is leading, and two sets of electromagnetic two sets of rotating fields will be produced, which will be moving in the opposite direction. And therefore, the strategy is that I will then find out the torque developed for this machine. It is a balanced two phase induction motor. This is also a balanced two phase induction motor, but for physical reasons I know that that the torque developed by these two sets of magnetic field will be in the opposite direction. That was the idea. And after doing that, I told you that okay, let this induction motor, whose rotor is this, okay, whose rotor is this, and suppose the rotor is moving, okay, at some speed nr, and this is your main winding, and this is the assumed auxiliary winding having no current. So the field, these two fields, one field is moving along the direction of the current, it has to be one of them. Whichever moves along the direction of the rotation, how this NR is obtained? I told you observation wise it was NR, let us assume it is having some speed, at that time I have switched on the main winding. Like that you can also think. Suppose the rotor is given a rotation NR and then you switch on the supply, then you will see it is running. So NR may exist because of some external disturbance like helping the rotor initially. So, let us assume then the general case when the rotor is moving NR and then you have got two machines, IM1 and this is IA1 and plus this machine, and here it is the direction of the field is like this, and this field we will call forward field, and similarly here it will be like this, and this is the I bar M2 and this is I bar A2, positive and negative sequence component, but in this case this current leads auxiliary winding. So, rotating field will be moving in both the directions. So, both these fields are simultaneously present and rotor of course is rotating in the same direction, NR. Therefore, I will find out the torque of this machine and this machine. So let us define that the slip of this forward motor, this is backward rotating field in this direction, backward rotating field. Therefore, slip is Ns minus Nr by Ns. What is Ns? Depends on the supply frequency and number of poles of the machine, we know that. And what will be the slip in this case? Backward field will be also moving with a speed Ns. Its speed is Ns in the clockwise direction, this speed is also Ns, this speed is Ns in the opposite direction. So, in this case the slip of the backward motor SB, okay, you can write SF if you like, forward field, forward motor slip, it is equal to minus Ns minus Nr by minus Ns, and this we have shown to be equal to 2 minus S, is not? This is 2 minus S. So, then I say that look here, this is the situation. So, what will be the equivalent circuit of this balanced two phase motor? Its equivalent circuit will be R1 X1, R1 X1. Then here is at any slip when it is running, it will be R2 dashed by S, and then this is X2 dashed, X2 dashed, and this is Xm. This is the per phase equivalent circuit of the forward motor. And what will be the per phase equivalent, and what is the voltage applied here? Is it V bar M? Is it V bar M? No, it is the positive sequence voltage V bar M1. Similarly, the equivalent circuit of the per phase equivalent circuit of this motor will be, the parameter values are same, stator resistance leakage reactance, and then you have here you have to be careful, R2 dashed, but the slip is 2 minus S, and then this is X2 dashed, and these two are Xm, and these are the per phase equivalent circuit of the backward motor, and its polarity will be plus minus, but this voltage I must call negative sequence voltage per phase, whatever you have applied. Now, since I bar M1 Acha, after I get this, it looks like it is now I can calculate torque. Okay. How I can calculate torque? That is, I can stop everything here and say what will be the torque of the expression I can find out without proceeding further. How? The torque will be, these are the resistances where air gap power is involved. This is the resistances where air gap power is involved. So, I will say torque developed by the machine will be, just see here, this is the thing. It will be this current square, let this current be called IF, forward field current, this branch current. So, it will be simply IF square, or I will write it at the bottom, TE will be in synchronous watt will be IF square R2 dashed by S. What is IF? IF is the current in R2 dashed by S, this branch. Then I will calculate this current. Suppose this current is IB, and this torque will be IB square into R2 dashed by 2 minus S. This is the expression of the torque, what else? Because these are the air gap power. And from physical consideration, I know they are moving in the opposite direction. So, I will put a negative sign. You can divide by 2 pi n s to get the torque in Newton meter, that is there of course. Anyway, this is the thing, but the question is you have to calculate this IF and IB, if you know. So, for that V bar M1 and V bar M2 is necessary. It is important to point out once again that while assuming our original machine is just this machine, there is no auxiliary winding here, only main winding, you have applied a voltage. These things I know, I will be knowing Vm, I will be knowing Im, actual current. Positive sequence, negative sequence is our own thought process led to that, so that I can analyze the machine like a balanced two phase motor, that is there, but neither V bar M1 and V bar M2 is known. When you come to this concept, this is the abstraction, okay, assume an auxiliary winding, it is not carrying a current, IA 0, but this voltage, about this voltage I cannot comment, I have not assumed V bar A equal to 0. What I am sure about, I bar A is 0, then only it resembles this one, as if nobody is there. Nobody is there means even if you consider there is a winding, it is not carrying any current, over. But if this fellow rotates, there is rotating fields produced by the main winding, I cannot say there will not be any voltage even in this winding, assumed winding, relatives, this is stationary. Therefore, how to calculate V bar M1 and V bar M2? Because that will be necessary to calculate this current and that current, IF and IB. Okay, there is a nice way out about this. I know this much, this is I bar M1, but that current is nothing but I bar M by 2. This current is nothing but I bar M by 2. Therefore, these two circuits can be connected in series. This is the connection I will make. And this was positive sequence voltage, this was negative sequence voltage. Therefore, this voltage must be your V bar M. That is the thing. This will be V bar M. That is, this is the V bar M. And this is the current, because this voltage I can record with a voltmeter, this current I can record with a ammeter. And therefore, these two can be connected in series, because I bar M1 and I bar M2 are same, and once you do that, everything is now in place, because V bar m will be known to me, all the parameter values are known to me, I know at what slip I am calculating the torque. I have to simply analyze this circuit and then calculate this current and this current in R2 by S terms, and then you say that the torque developed will be this one. Got the point? But only one still, whether something can be done about this circuit. See, in the original machine you apply a voltage, only main winding is existence, no auxiliary winding is there, you apply a voltage. You connect an ammeter, you know the current, or see in the oscilloscope you know at what phase, but completely I bar m is known. Then if you so calculation of IF now is possible, because I know IM by 2 is also then known, then series parallel this current division in parallel circuit I can do. But nonetheless, whether something better can be done. The next step is that okay, I will be knowing this voltage V bar m, I will be knowing I bar m, whether this circuit can be translated to that. Let us see. So, can I make this current I bar m by 2? It is now I am going now from machine, it has nothing to do with the machine, the next step what I am doing. What I am simply telling, you have applied a voltage V bar m, current is I bar m. What is I bar m by 2? It is equal to this voltage by this whole impedance. Then why not divide all the impedances by a factor of 2? Same voltage applied, then the current will be I bar m. So divide all the impedances by a factor of 2 and redraw the circuit, that is, I will do very quickly x 1 by 2, but this is a very important step, and then I will make it R2 dashed by 2s, all impedances I will divide by 2, x2 dashed by 2, this is magnetizing inductance xm by 2, and then once again that backward motor, it is connected in series. Oh, so there will be another R1 by 2, another x1 by 2, and these two parallel branches, that is R2 dashed by 2 into 2 minus s, that is what I am doing, and this is x2 dashed by 2 into 2 minus s. I have divided all the impedances, no, x2 dashed by R2 dashed by 2s, x2 dashed, this will be x2 dashed by 2, okay. And then you have xm by 2, and then you have this voltage V bar m. Now, what will be the current in this one? It will be I bar m now, because I have simply divided all the impedances by a factor of 2. And then what people do after this, this R1 by 2 you can combine, you get a single R1, you combine, you get a single this one, then this is of course R2 dashed by 2s, this is x2 dashed by 2, this is xm by 2, and this is this R1 to x1 by 2 I have taken here, and then these are these. This is R2 dashed by 2 into 2 minus s, and this is x2 dashed. This is xm by 2, and then this is Vm, and this is Im. Got the idea? So, this is the thing. Okay. Acha, now you tell me if this current was IF which I indicated and this current I indicated IB, what will be this current now? It will be twice IF, this will be twice IF, and this current will be twice IB, backward motor current, is not? This will be the thing. While writing this torque from this machine, what I did, I calculated the air gap power here and the air gap power there and multiplied with IF and IB. In fact, there are two phases, so it should be multiplied by 2 and 2, is not? Total torque, it was per phase torque, but total torque is this. Now, what do I do with this? This one if you see, I want to calculate torque. So, it will be power in this resistance. So, R2 dashed by S into this current square 2 IF squared and minus R2 dashed by 2 into 2 minus S into 2 IB square. But IF, IB are these currents, mind you, in that current, in terms of this current I have calculated. This is the thing. If you simplify this, it will be 4 R2 dashed by S into IF square minus 4 R2 dashed by 2 into 2 minus S into IB square. R2 dash by 2S and here it is correct. So, I will rewrite because this is an important step, thank you. R2 dashed by 2S, I missed this 2. So, R2 dashed by 2S into IF square minus R2 dashed by 2 into 2 minus S into this 4 into IB square, is not? And this will be equal to 2 R2 dashed by S IF square minus 2 R2 dashed by 2 minus S into IB square. Is that clear? So, I will not first write TE here, I will calculate the power in this new equivalent circuit. Power in this, it has something to do with air gap power. So, I have calculated this and then I discover this is nothing but the torque calculated earlier 2 IF square R2 dash by S minus 2 IB square R2 dash by 2 minus S. That is, in other words, what I am telling, this is torque. Do not multiply it once again by 2 saying that it is per phase. Why? Because the moment you divide all the parameters by 2, all the resistances has become half and current has become twice. So, power will be twice. Understood? That is an important step. Therefore, the final equivalent circuit if you do, that is Vm and then your Im, this is the final equivalent circuit. You do it, calculate this current and this current, and this current square into R2 dash will give you total air gap power taken two phase together, that is what I am telling. Similarly, that is there, and then this power minus this power by 2. Anyway, I will continue in the next class.